Today we're going to continue on from last time. Do you guys remember last time we grabbed a parabola, right?
Yeah.
So it looks something like this. It's the same exact parabola from last time. H of x equals to x squared minus 6x plus 4. Let's review a little bit. Last time I said that we were really lucky because we were able to include the vertex as we were doing a table, right? We just started with 0 and then we kind of kept on going. But who remembers? How do we then figure out, Emily F., what do you think the x-coordinate of the vertex is from last time? Right? How do we figure out it was 3? Do you remember? Because, when you're doing your homework, I told you have to actually figure out your vertex first. So, Elizabeth, do you remember? Well, the question is, how do we figure out the vertex is 3 on this one? Do you remember from last time? Right, it's right in the middle, but we were lucky because we started off with 0 and 1, 2, 3. But I told you that it's not always going to be worked out. It'll work out like this, right? You have to actually know where the vertex is. And remember, yesterday I told you this magic formula that tells you the x-coordinate of the vertex. You don't remember? Yeah. You remember now? Exactly. We knew that it was x equals to negative p over 2a. And when you plug that, what is your a on this one, by the way? 1. A is 1. Remember, this is the coefficient of this invisible one. A is 1. B is what? Negative 6. Do we even need the value of c? No, but we'll just keep it there, okay? For now. So remember, when you plug in negative b over 2a, right? You get 3, right? Do you remember that? How do we get 5 then? Negative 5, I mean. How do we get negative 5, this value? Who remembers? How do we get negative 5? Judy? You plug it back in. You plug it back. In other words, this negative 5 is really another name for negative 5. I mean, let me do it right here. Another name for negative 5, Judy, is what? H of 3, right? That 3. And do you guys remember how we got 3? It was negative p over 2a. So, who thinks they know? Because this is now the sort of a summary of who thinks they know if I give you an equation ax squared plus if I give you an equation ax squared plus bx plus c, so let me write it down, hold on. So knowing what we just did, it turns out if you have any quadratic equation, f of x equals to ax plus bx plus c, who could tell me the vertex of any quadratic function? How would you now? We did one for an example, right, that we did yesterday. But what if now you have a general? Right? Doesn't this describe every possible quadratic function you could get, right? A, B, C could be any numbers you like. Of course, A can't be 0, right? Because if A is 0, you get a linear. But if I have f of x equals to ax squared plus bx plus c, what's my vertex? First of all, what's the x-coordinate of this vertex? One person knows? Okay, I want you to all think about it as a group. How would you represent in other words, what's the formula for the vertex for this general formula? Negative b over 2a is your formula. Well, for x coordinate, right?
Oh, yeah.
So then what's the y coordinate? Me. One person? No, I want you to think about it as a group. Go ahead. What would I write? What should go in there? Go ahead, everybody. Anybody? What goes in there? How do we represent the y? So a lot of you said plug it in, right? You plug in negative p over 2a to this, right? So how do you write that nicely in there as a y value? No one knows? Really? Okay, go back to that example. We found h of 3, right? So instead of h of 3, it should be what? Yeah.
So is it going to be like a and then a negative b over 2a squared?
Kind of. Okay, look at the previous example. We said that the vertex was 3, negative 5, right? Well, how did we get 3? That was negative p over 2a. How did we get negative 5? Plug that 3 into the equation. How do we then say this? Don't we have to plug in negative p over 2a into the equation? So what's another way of saying what is the value of y when x is equal to negative p over 2a? Using the function. Yes, Owen.
H of
Exactly. Well, this time it's f. F of negative p over 2a. Isn't that how you say what is the value of y when x is equal to negative p over 2a? You see how nice it is? It's a nice way. Yeah.
And then I like plugged it actually in
Well, you got an answer?
yeah.
Oh, you actually plug this in here?
Yeah.
Oh, what'd you get?
Like AB squared over 4A cubed. B squared over 2A plus C.
Good. Would you like to write that, or would you want to write this? Yeah. Okay. There you go. There's my point. Okay. You're right. It's always going to work out. But do you see what I'm talking about? Remember why we talk about this whole function notation? Rather than writing that long sentence, we could just write simply f of negative p over 2a. That just means you plug in negative p over 2a for your value of x, and what's the y value? Well, that's the y value for the vertex. Does that make sense? Just like, you know how we plug in 3 to this? We got the y value of negative 5? Well, that's after all h of negative p over 2a, right? This negative p over 2a happens to be 3, so that's what we got.
So it's gonna be a times the negative b over 2a squared plus 2a plus b times negative 2a. Like, never mind.
Right. Just as if you were, but normally, Shirag, when you do the problem, you're not gonna you're gonna actually figure out it's gonna be a number. Just like the previous example,
Oh.
what is negative p over 2a? It just simply becomes 3. So you don't have to plug that whole thing in. You're gonna just plug in numbers. It's a lot easier that way. You know what I mean? So in real practice, yeah, you're not gonna plug in all this like this. You're gonna plug in that actual number, whatever it comes out to be, negative p over 2a. Okay. Right, good. So let me go back to that graph again, and when this parabola. By the way, on your homework last night, remember I told you don't worry about these other sort of question rather than just graphing. What other question did they ask you? Did they ask you to find the least value?
Oh yeah. Well,
Did they ask you to find the greatest value?
Yeah.
Okay. Well, let me take a look at this graph. And I told you it's going to be really simple idea. When you look at this parabola, what do you think? This parabola has a least value. Let me just tell you that much. What do you think? What do you think the least value is? Raise your hand. So this parabola has a least value. It does not have a greatest value because, well, we'll explain that in a minute. This parabola has a least value. Talene, what do you think least value is? Almost. It's almost like it's the vertex, but which part of the vertex? The y coordinate of the vertex. You're right. What do you think? Okay, so what's the y coordinate? It's negative 5, right? Why do you think, so the least value for this graph is negative 5. Why do you think we call this negative 5 the least value? Okay, I want you to think about it as a group. Go ahead. Why? Why do you think it's to talk about this as a group? Who thinks they know why negative 5 is the least value? What are they describing? Emily?
Because it's the vertex, so it's the lowest point of the, so there's one.
Yeah, least value is the lowest point of the graph. That's all it is. Okay, where's the lowest point? Well, is it going to be x? Can I talk about x coordinate for lowest point?
No.
No, x is left and right. Which one gives you high and low of the point? The y coordinate. So it's the y coordinate of the vertex. That's the least value. It's negative 5. By the way, they only didn't ask for least value, but they also asked for. What do you think? By the way, do you think this will have greatest value? No, this one shoots up forever, right? It goes up, right? It's a y-axis forever. So it's infinity. But when, now think about this as a group, when do you think we get a greatest value of a parabola? Go ahead, think about it as a group. I'll give you time. Because there are times where you get a greatest value, okay? Who thinks they know when we get the greatest value? Matthew.
Like when the parabola is like upside down.
When parabola is upside, how do we describe it? Yes, you're right. Upside down parabola means it's what? Opens downward when a is negative. So here, whoops, not this one. Right, right now, you look at my parabola. Do you think I have a minimum value or maximum value? Minimum value, where is it at? At 2. Okay, now let me change the value of a to something else. Right now, look at my a, it's positive, right? Let me make it, oh, you don't see? It's not, negative 2. Let me move this up a little bit. Okay, we'll learn this later, okay? So, now, do you think I have a maximum value?
Yes.
What do you think my maximum value of this parabola is? 2. Maximum value is nothing more than the y coordinate of the highest point, which is, where is the highest point? Which is on the vertex. It's always the vertex, isn't it? Do you guys understand? So, let me show you what I wrote down here. So let me summarize what we just talked about. You're right. It's really nothing more than here. So write this down. Oops. Where is it? There you go. If parabola opens upward, you see the picture? Okay. They call it either minimum point. Point means order pair, right? What's the minimum point, by the way, for this sort of? Isn't it a vertex? Okay. Right? Is a minimum point vertex?
Yeah.
Or the lowest point, -3 comma -5 for the previous example, or you could write for general -b over 2a comma h of -b over 2a. What is then the minimum value you think? I mean, yes, what do you think the least value is for this when it opens upward? Okay, if the parabola opens upward, it has a minimum point or vertex or lowest point, 3 comma -5 for the previous example, or for general -b over 2a comma h of -b over 2a. What do you think my least value for this parabola is, guys? Yeah. -5 for this one, in general, it'll be the y value, which is lowest value, which is h of -b over 2a, exactly. Okay. So the y coordinate is the least value of the vertex, okay? In other words, h of -b over 2a. Does that make sense? Do you get the idea? This is exactly what you told me, right? If you have a parabola that opens upward, least value is the y coordinate of your vertex. Well, what is that y coordinate? When you plug in -b over 2a for x, which is h of -b over 2a, right? Good. Do you think we have, what do you think fact 2 is going to be? It's the other way around. When a is what? This time a was positive, when a is negative. You guys need more time to write? Okay, let me leave it. Okay. So fact 2 is nothing more than, so if parabola what? Opens, anybody? Downward, I'm going to change that. And then it has a minimum point or maximum point? Maximum point, is that still the vertex then? Yeah, of course. Or the maximum point at, well, we don't have, well, -b over, it's same point, the vertex, right? And then the y coordinate is the least value or the greatest value? Greatest. So here it is, exactly right. There we go. It's the same exact thing. So I call it g of x now because it's a different function then. So the parabola if parabola opens downward, then it has a maximum point vertex or highest point at -b over 2a comma g of -b over 2a. That's just nothing more than y value of that, right? Vertex. Does that make sense? How do you figure out the y value? You plug into the function. Then the y coordinate is it's not the least value anymore. It's the greatest value. Okay? So that's the difference. That's the only difference. And how do we know it opens downward when a is what? Negative. Okay, there you go. Okay, write it down. You give it time to write it. So, as you can see, what other thing then did they ask you other than the maximum value, the greatest value or the least value? What else do they ask you? On your homework, have you noticed? Yes. Yeah, and we know how to find the vertex. So other than vertex, the greatest value and least value, what else do they ask you? They also ask have you something called axis of symmetry. So here, you see this blue dotted line? I have drawn the axis of symmetry. By the way, what do you think axis of symmetry is? We sort of talked about this a little bit. Raise your hand. Aaron?
The middle of the parabola to make it even.
Okay, good. Anybody Lara, do you want to add something to that? And what kind of line is this? Cameron? It's a vertical line. So first of all, it's a vertical line. What else? What else does it do? Because how many vertical lines are there? Infinitely many. Now, what sort of vertical line do they want? Owen? That divides the parabola into two equal pieces. Okay, fine. So that's why it's symmetrical. That makes it symmetrical. So in other words, this vertical line has to pass through what? Vertex. Do you guys understand? So there's my blue line. Do you all see this? Do you see how this blue line makes this, cuts this parabola in half, like to the left and right of it? Now, what's then the equation of this axis of symmetry? Because when they ask for the axis of symmetry, they actually mean the equation of the axis of symmetry. What is the equation of this vertical line here? Chansu? X equals to 3. Isn't that right? Does that make sense? Why is this x equals to 3? Why not y equals to 3? Why not, I don't know, some other, yeah. Yeah, first of all, it's a vertical line. Then for vertical line, guys, listen, this is important. For vertical lines, you know that what? Y's could be any numbers you want as long as x is fixed, right? Why is this x fixed to 3? And do you think it's coincidence that this 3 is the x coordinate of the vertex?
Yeah. No.
It's not a coincidence. Yeah, Kobe?
Because like if x isn't equal 3, it's not gonna go through 3 and 5.
Exactly right. If x is not 3, will this vertical line pass through the vertex at all? No. That's why in order for this, right, axis of symmetry, right, to pass through the vertex, the equation of this axis of symmetry is equal to x equals to the x coordinate of the vertex. Otherwise, it won't go through it, right? Do you understand? So do you see the pattern here? So let me, hold on. Let me see. So who thinks then, now that we have learned that, okay, who thinks for f of x equals to ax squared plus bx plus c, what do you think the equation of the vertical line that contains the minimum or maximum point, which is the what? Vertex, right? When this vertical line goes through the vertex, it's called the axis of symmetry. What is the equation of this thing? For this general formula. One person?
One person's on
I know, but I want to, okay, so take a look at these. Picture. So I have, what do you think the equation of this vertical line is? That passes through a vertex 1, negative 3? Raise your hand. What's the equation of this vertical line that passes through the vertex 1, negative 3? One person sees still? Two. Okay, I want you to think about this as a group. Okay, what about this one too? Okay, the one that goes through 3, 4. What is the equation of this axis of symmetry? Go ahead, everybody think about it as a group. I'll give you time. So first of all, who thinks they know the equation of this axis of symmetry right here that passes through the vertex at 1, negative 3? Yes, Lindsay. X equals to 1 is correct. What about the other one? What's the equation of the line? Andrew? X equals 3. I wrote it down right here. So anybody see any sort of pattern? What do you think the equation of this vertical line is always going to be? One person. 2 now. At least better than 1 now. 3. 4. Anyone else? You guys, you don't see a pattern? 5. Lara, what'd you guys come up with? It's what? Say it again. Okay. Okay, Cameron, what do you think?
It's always the x value of the vertex.
It's the x value of the vertex, right? X equals 2. So what's a better way to write that? X equals to what? Kobe?
Negative b over 2.
Yeah, exactly. Negative b over 2a. Isn't that the x coordinate of the vertex? It's always going to be the x coordinate of the vertex, right? Because the vertical line is going to be x equals some number, right? Since it has to go through the vertex, it's the x coordinate of the vertex. Everybody got that? So, does this make sense? Okay. Any question? So I wrote down the see, x equals to 1. You see, it's the same as x coordinate. X equals to 3, same as the x coordinate of that vertex. All right, then if you got that, can you, example 1, finally, example 1 of this section. Can you tell me the vertex, axis of symmetry, and least or greatest value of this function f, colon, x, arrow, 2x squared plus 4x minus 3. By the way, what is this notation? Same as? Does you guys remember this arrow notation? This is same as what? Equals what? Somebody tell me what? How to rewrite this using? Yeah, it's just f of x equals to 2x plus 4x minus 3. So don't get that confused, guys. When they give you this arrow notation, you can just rewrite it as f of x equals to 2x squared plus 4x minus 3. Do you see that? Don't be scared of this arrow notation. It's nothing more than this. Does that make sense? No, because people see that, oh, it looks different, and you know what I mean? Okay, go ahead, try this now. Some of you are confused. First of all, well, let me show you that this is, okay, hold on, guys, stop talking. Okay, guys, may I talk? Here. What is, first of all, the vertex? How do you find the vertex? You have to find, we know the x coordinate, so yeah.
So, like, do I just like say the?
Well, first of all, what's your A for this?
Oh, A is 2.
What's your B?
Is negative.
B is negative 3? No. That's C. B is what, guys? 4. C is negative 3. Right? So you gotta get that right first to get the vertex, don't you? You guys understand? A, B, C? Okay, these are the, hello? Guys, these are the coefficients of the terms, right? The quadratic term, linear, and then constant term. Okay. Who has the x-coordinate of the vertex? Malia, what did you guys get? -1? You're right. Because when you plug in vertex negative p over 2a, don't you get -1? Okay, so once you get -1, how do you find the y-coordinate of this vertex? Emily, you plug into the function. Who's got that one? What's f of -1? Allie? -5. Okay, if you don't believe me, look, here's the work, guys. Alright, verify that you got negative. If you didn't get -5, that's not good. Okay, it's -1 squared times 2 plus 4 times -1 minus 3, right?
That's 2 minus 4 minus 3.
There you go. So, alright, you better get -5, otherwise.
2 minus
Right?
4 minus 3 is not -5.
You guys get it now?
Wrong, I have a question.
What? Hold on.
Is it 2 minus 4 minus 3? How's that -5?
What are you talking about?
Oh my god.
Hey, guys, you better know how to add and subtract numbers. Really, come on. Are you serious? 2 plus -4 plus -3 if you want to make everything to addition. Be careful, okay? Alright. Hey guys, look. Isn't this where f of -1 came out? Look, guys. Right here. What's f of -1? -5. So what's the vertex? -1, -5. Any question? Class? If you know your vertex, listen. Shh. If you know your vertex, you're really done with everything else. Because vertex gives you the minimum or the maximum. Hold on. Yeah, it gives you the axis of symmetry and the minimum and the maximum value. By the way, for this one, is this going to give us the minimum value or the maximum, least value or the greatest value? It'll be the least because your A, hold on. Your A is positive. Therefore, it opens up or down? Up. So you get A. Class, what do we get? We get A. Least or greatest value? Okay. Matthew, what's our least value? It's -5. It's the y coordinate, not the x coordinate. What does the x coordinate give you? That gives you the axis of symmetry. There you are. Okay, so you should have all gotten this. Okay, verify you get the right answer. Guys, x value gives you the axis of symmetry. Y gives you the either least or the greatest. Well, this time it's going to be least, right? It opens upward. Okay. Do you guys remember f of x versus f of x equals 0? On your homework, they call it f of x equals 0, zeros of the function. Okay, so just keep that in mind when you see that. You know, oh, it's f of x equals 0. They even tell you that. Anyway, so what's the difference? Is there a difference? Raise your hand. Who remembers? What's the difference between f of 0 versus f of x equals 0? Maddie.
F of 0 is your function is like what happens when it is 0.
What is? I mean, what is it? X. When x equals 0, it's x. Yeah, that's right. Yeah, which values of x makes this y equal to 0? Does that make sense? So here's a function. You guys remember doing this? So who thinks they know what f of 0 is? That's easy. Part A, f of 0 is going to be 10. Right? You plug in 0 equals to, x equals to 10, and you get what, guys? 10. Right here. How do you find f of x equals 0? Oh, okay, Aaron, tell me what's right. Exactly. Tell me what's right. Excellent. So you've solved now. When would this whole thing equal to 0? Which values of x, right, will make this whole thing equal to 0? So you say 0 equals to 2x plus 10, and of course you subtract 10 from both sides, divided by 2, you get? -5. And here, the order pairs you get is 0, 10 for f of x equals 0, right, because your x is 0. Here, you get -5, 0. In other words, when you plug in x equals to -5, your y is 0. Right? So you're going to see something like this for your homework tonight, but it's not going to be this straightforward. What if they give you, now, quadratic? Go ahead and find f of 0 and f of x equals 0. Go ahead, I'll give you time. Let's see if you guys remember. Okay, so how many of you got f of 0 already? Okay, what did you get, Judy? It's 8. Any question? You plug in x equals 0, all the terms with x goes away. They go away, and then you end up with 8. Now, what about f of x equals 0? How about, who haven't I called? How about Derek? What would you write? I'm sorry? So, if f of x equals 0, then what? This f of x, in place of f of x, you're going to write 0. So then you solve for, you guys remember how to do this? Using the zero product property, what do you hope to do with that trinomial? Factor. That's the only way you know how to solve. Remember, when the whole equation, right, that is not linear, right, equals to 0, you got to factor. Does this factor?
Yes.
How's it factor to?
X equals x negative 4, x.
Yes, x equals x negative 2 times x negative 4. So that means, when is this equal to 0? This is only 0 if and only if what? If x minus 2 equals to 0 or x minus 4 equals 0. When is that? There you are. There are two possible cases. When x equals to 2, the whole thing becomes 0. When x equals to 4, the y value is 0. You guys remember this? Factoring? Yes? All right. Okay. Good. So before we go today, I want to kind of give you a little kind of pointers when you graph. Like number 9 from last night's homework. When h of x was equal to x squared minus x minus 6, I'm sure you all got the vertex as equal to, I think, came out to be half or something, right?
Yeah.
So it was half, and 6 and 1/4 was your vertex. Now, remember I told you you need 2 other points to the left of this and 2 other points right of this?
Oh yeah, what's left and right?
Now, are you going to use like fractions to plug in? So which points would you use when you're doing a graph? Yeah, I would actually use, do you think I'm going to use 0 and negative half or something like that? No. You could use any 2 points left of 1/2, the vertex, right? So I would use nice points like 0 and negative 1. And on the right, you could go by halves, and then are you going to do 1.5? No, just do 2. Why make it hard, right? Because you could plug any 2 points on the right side of it. You don't have to always go to the same unit. Does that make sense, guys? So make your graph easier. Now, also, but do you expect to get then same y's, just like the other ones for these?
Yeah.
Not quite, because you're not moving the same distance away from the vertex. So your y's may look a little bit different than, all the other ones, right? The y's on the left of the vertex, they're all the same, remember? But it may not happen on this one, right? Because you're not choosing the values of x that are equidistant from the vertex. Do you understand what I'm talking about?
Can I ask my question?
Okay, hold on. Does this make sense, guys?
Yeah.
So can you choose nice points? You don't have to choose for like fractions, okay? Just because the vertex is a fraction. Do you understand what I'm saying? Okay, good.